Today's lesson, we're going to introduce parametric equations. Now, up to now, we've been graphing rectangular equations, and those are just a fancy word for those equations in terms of x and y. For example, y equals mx plus b is a rectangular equation with the variables x and y. So rectangular equations have two variables, x and y, which are graphed on our Cartesian plane. The graphs of rectangular equations trace the path of the object. A parametric equation, on the other hand, adds a third variable, which is time. And it's in the form of x equals an equation as a function of time and y equals an equation as a function of time. So our graph of parametric equations not only traces the path of the object, but it also tells us where the object is at any given moment in time. For example, let's consider the path followed by an object that is propelled into the air at an angle of 45 degrees. And the initial velocity of the object is 48 feet per second. Then the object travels in a parabola path given by the equation y equals negative x squared over 72 plus x. This is the rectangular equation of the graph, and it should look like the graph below. However, this equation does not tell us the whole story. Although it does tell you where the object has been, it doesn't tell you when the object was at a given point x, y. To determine this time, you can introduce a third variable, t, which we call the parameter. By writing both x and y as functions of t, you obtain the parametric equation. Our parametric equation is x equals 24 square root of 2 times t, and y equals negative 16t squared plus 24 the square root of 2t. For this set of equations, you can determine that at any time, for example, t equals 0, the object is at the point 0, 0, whereas at time t equals 2, the object is at the point 24 to the square root of 2 over 24 to the square root of 2 minus 16, and at time, and so on. So we can do any time when we want. But the key is, with a parametric equation, notice that we also include this arrow that indicates the direction of the path of the object. This type of graph, when we graph a parametric equation, the resulting path is called a plane curve. So, definition of a plane curve. F and g are continuous functions of t on the interval I. Then the equation x equals f of t and y equals g of t is called the parametric equation, and t is called the parameter. The set of points x and y obtained at t varies over the interval I is called the graph of the parametric equation. Taken together, parametric equations in the graph are called the plane curve, denoted by C. Okay, so let's talk about how to graph parametric equations by hand. The first step that you're going to do is you're going to make a table of values. This table is going to have three variables in it, t, x, and y. Next, you'll have to determine some values of t on the interval given that will give you enough information to trace the path of the object. So sometimes you might have to choose more than you originally think. You have to get a good image, a good picture of what the object is doing on that entire interval. After you completed the table, then you're going to plot those points from the table, plot each x and y value on your graph in order of time. Then connect the dots with a smooth curve to make our plane curve. And then all it's left to do is to put directional arrows on your graph to trace out the path of the object and to label your graph with the equation. So in summary, the steps to graph any parametric equation by hand or a plane curve is 1. Make a table of values. This should include t, x, and y. Then plot the xy points, and then put directional arrows on your curve and label your graph. Example 1, let's sketch our first parametric defined curve. So step 1, we need to make a table of values. On my table, I'm going to include t, x, and y variables, and I'm going to do it between the intervals of 0 and 2. So let's try 0, 1, and 2 and see if that gives us enough information to sketch our curve. My x parameter, I'm going to replace every t with 0 and simplify the equation. So at time 0, I have an x value of -1. I'm going to repeat this for the y parameter. In that time 0, I have a y parameter of 1. I'm going to repeat this process at time t equals 1 and time t equals 2. Simply plot your 3 xy points on your graph. After you plot those points, connect the points with a line or a curve, in this case a line, and then put a directional arrow onto your graph to show which path or which direction the points were plotted. And now you have graphed your first plane curve graph. Second objective to the day is going to be to convert parametric equations back into rectangular equations. So the first step on this equation is you're going to look at your two parametric equations, and if it is possible and easy to do, solve one of your parameters in terms of t. Step 2, then you're going to go to your other equation that you did not use, and you're going to replace that expression or substitute that expression into the second equation and simplify, and you should have an equation in terms of x and y. Let's use that example 1 that we had on the last problem that we just finished graphing, and let's rewrite this parametric equation into a rectangular equation. Okay, step 1, we're going to solve one equation for t. I'm going to choose the bottom equation because it's easier to rewrite this as t equals. So t is equal to y minus 1. So now I'm going to move to the other parametric equation, which was the x equals 2t minus 1. And this time I'm going to replace every t in that parameter with y minus 1. Simplifying down the equation, I end up with x is equal to 2y minus 3. And then if I could get y is equal to, then solving for y, I find y is equal to 1/2 x plus 3/2. For the next couple examples, we're going to put it together. So I'm going to, on example 2, sketch the plane curve and then convert the equation to a parametric equation into a rectangular equation. So we're going to start by sketching the plane curve. Remember, the first thing we need to make is a table of values of t, x, and y. And then we're going to pick some values of t on the interval from 0 to 2. So I'm going to start with 0, 1, and 2. And then I'm going to replace since x is equal to t, I know my x is very easy to figure out. And then y, I'm just going to substitute these in. So I'm going to start by replacing every t with 0 and then simplifying, and then repeat that for time 1 and time 2. Unfortunately, these 3 points are only giving me a triangle shape of my graph, and I don't think that's enough. So I'm going to add a couple more points, and I'm going to see if this will help me get a better idea of what my picture looks like. Now I chose 1/2 and 3/2. Now notice I kind of did the equal distance between each of those 2 points in my intervals. It's usually nice if you can keep your values equally spaced out. So now I'm counting by halves instead of by 1. But I'm going to repeat the same process as I did before to find my y parameter. Now let's use these 5 points to plot our graph. So I notice my domain is going from 0 to 2. My range is from 0 to 1. And let's plot each point. So now I'm plotting the 1/2, then the 1, then the x equals 1 and 1/2, and then finally x equals 2. So we have a parabola in this shape, marking my path with arrows. That is the graph of the plane curve. Next, let's rewrite this parametric equation as a rectangular equation. Since we already have t is equal to x, all I have to do is, in my second equation, replace every t with x. And there is our rectangular equation for this parabola. Our next example is try a parametric equation that involves a trig function. So we're going to start this just the same. So in order to graph this parametric curve, we're going to make a t-chart. Now I'm going from 0 to pi over 2. So let's count by a pi over 4, or 45 degrees. And let's see if these 3 points will give me enough information. So I'll start by replacing every t with 0 in the x equation. But let's rewrite that x equation as 2 times sine of t quantities squared, because that'll be easier in my algebraic manipulations. And then I'm just going to evaluate at time 0 and figure out my x and y points, and then time t over 4 and time t over 2. Let's try sketching these points and see if these 3 points are enough or if we need more information. So my range is from 0 to 2. My domain is from 0 to 2, and my range is also from 0 to 2. And let's plot our first point, 0, 0. Second point, and then our third point. So this appears to be a curve that's connecting those dots. And then I've traced an arrow in the path in which we're doing. We plotted the times, and that is our parametric graph. Now let's rewrite the parametric equation as a rectangular equation. An example of a time where it's not convenient to solve for solve for just t by itself. It's very difficult. But I notice I got sine of t in both of my parametrics. So let's just solve one of the equations for sine of t, and then substitute sine of t in instead of t, and simplify the equation. So my rectangular equation for this problem would be x is equal to 1/2 y squared.